Hi everyone, I hope you're doing well. In this video, I will show you the difference between DevOps, MLOps, and LLMOps. So to give you an idea about what each term means, for DevOps, it's actually the combination between two words, development and operations. For MLOps, it's actually the same term DevOps, but applied to ML, which stands for machine learning, and LLMOps, it's actually MLOps, but applied on a specific case of large language models, or LLMs for short. Let's start to have more details about DevOps. The main goal of DevOps, it's actually automating software development and delivery process, which improves speed and boosts efficiency. With that, we avoid all manual processes in development software, which are not only slow, but also error-prone and insecure. There is a whole life cycle behind DevOps that you see here. It starts with planning, which consists on planning for tasks. This is followed by coding, so developing code in collaboration, followed by building applications, running tests to validate this code, release a new version once the code has been validated and ready for deployment. Once deployment is done, operations steps take place, which is related to applications infrastructure, including scaling when needed, security, data management and backup, and recovery. Once the infrastructure is set up, we need to monitor our application by tracking its performance and errors, identify issues or areas for improvement. We talked about deployment, but to ensure this, we generally need three main environments. The first one, development environment, which is for developers to develop the code and the application. We have the staging environment, which is for testers to test the functionality of the application. And the last one, which is for users and is the production environment once the application is in production. A version control tool like Git is necessary as well to manage code changes. CI/CD are two other core concepts of DevOps, which consist on building and testing code changed once commits and automating the release of this tested code. Thanks to all these DevOps pipeline, we have an improved collaboration between development and operations teams. We have superior quality and security, thanks to CI/CD and proactive security measures. And of course, improvement is still ongoing, thanks to continuous feedback from users and testers. Let's talk about MLOps now. As mentioned in the beginning of this video, MLOps extends DevOps to the machine learning lifecycle. So instead of managing only the code, we add data used to train and test models and models themselves. So here we are not talking about developing code in general, but about developing code for training and test machine learning models and all processes related to their deployment and managing. Now, these new parts come with their challenges as well, because all the build and test pipelines are not triggered only by code change, but also by data when new data arrives, for example, or by new model when new architectures appear, or even other new models used in the application. Now, you noticed, guys, that I mentioned the word data many times because these kind of applications are data-centric, because training and testing machine learning systems, and so their performance as a result are highly dependent on the data it's trained on. New core components come with the new term of MLOps, which are model registry, which is a centralized repository for trained models used to score them and track their performance. Many tools exist. Among them, we cite MLflow, weights and biases, and CommitML. There is a store for features as well, which are features used for training or inference. Also, there is a metadata store, which stores information related to model training, and this is used to trace models' characteristics and analyze better their performance. Last but not least, we have what we call an orchestrator, which, as its name indicates, automate the sequence of steps in machine learning projects. And there is no surprise to see DevOps principles for MLOps as well, including the automation part for efficient retraining and deployment. We have versioning, but not only for code, but also for models and data. Experiment tracking using tools like MLflow, weights and biases, and CommitML. Always testing code, but also data and models. Monitoring to detect performance degradation in production. And reproducibility by tracking moving variables to ensure producing consistent results. Now, in the last part of the video, I will present LLMOps, which is, as mentioned in the beginning of the video, is a subfield of MLOps, but oriented to the specific field of LLMs. As it's a subfield of MLOps, it inherits the principles of MLOps and DevOps. As LLMOps is focused on LLMs, it focuses on the key areas of LLMs, which are, first of all, prompt engineering. So it focuses on versioning, testing, and monitoring prompts. Guardrails are more than important as well to control LLMs' inputs and outputs, to prevent harmful or toxic behavior or private information leak, which are cases that happened in the past and still happening in the present, but there are many improvements and techniques that have been put in place to avoid this unexpected behavior. There are feedback loops as well to ensure systems' continual improvements. This can be done by collecting users' feedback and fine-tune LLMs on these feedbacks. Cost management is very important as well, because these kind of models tend to have high computational costs. LLMs are known to be at a massive scale with trillions of tokens for training when we talk about training from scratch, and this comes with scaling challenges. That's why small and medium companies tend to adopt pre-trained models that they fine-tune, or they prompt engineer on them, or they do both, rather than building models from scratch. As is the case for DevOps and MLOps, automation is present for LLMOps as well. Also, the CI/CD pipeline to test and deploy the LLM-based application, but this time continuous training is added because developers tend to fine-tune LLMs when new data is present, or when they are unsatisfied with the performance, or even to take again the checkpoint of a model and fine-tune it on a new use case. And of course, all this pipeline is monitored to track used prompts, the generated response, the model's performance, and the total costs. This is it, guys, for today. Thanks for watching. Please don't forget to subscribe to the channel to have more videos like this one. Don't hesitate to ask me questions in the video comments about any concept about which I talked so far. Here I put sources of information if you need to have more readings on them, and see you next time.